The deep, thick forests of North America harbor numerous secrets, each thicket or hollow hiding a new mystery. In the late 19th and 20th centuries, the woodsmen and lumberjacks tasked with reining in this wild country were among the first to describe some of these mysteries in the modern age, each one seemingly more bizarre than the last. One such legend originates in the hemlock forests of Pennsylvania. It is not a fearsome creature, quite the opposite in fact. Rumors told of a small, ugly creature, so hideous that should it catch a glimpse of its reflection, it was prone to uncontrollable bouts of weeping. Even stranger, it was said that if threatened, this creature may even entirely dissolve in its own tears. At first read, this may seem like nothing more than whimsical folklore, but as with so many legends, there is always a grain of truth. In this recording, I will provide a detailed account of the anatomy, physiology, and behavior of this organism, a creature whose common name is as odd as its biology, the squonk. I must admit, when a report of a creature known for its morbidity and ability to dissolve into a pool of its own tears came across my desk, I thought it to be some attempt at humor by someone on my team. Amazingly, however, this turned out not to be the case. Somehow, the reports of the squonk had been deemed worth investigating, and after determining the legitimacy of this assignment, I had no further qualms. After all, I have yet to be assigned an investigation that did not lead to at least some form of fruition. Preliminary investigation revealed that much of what is currently documented about the squonk comes from a single entry in a booklet published in 1910. Additional, albeit infrequent reports were published throughout the 20th century, but they provided little additional information. In any case, according to these reports, the squonk is a small, pig-like creature of morbid disposition, shy and reclusive. It is most notable for its apparently wart-covered and ill-fitting skin, an aspect of its morphology that allegedly causes the creature great anguish, leading to a near constant stream of tears so thick that its watery trail can even be used to track it. Even more unbelievable, however, are certain reports of this creature weeping so uncontrollably, particularly when threatened, that it will effectively dissolve, leaving behind only a puddle of bubbling tears. And so it was that, following these reports closely, we began an exhaustive search into the deep and isolated hemlock forests of Pennsylvania. Surprisingly, in speaking with the locals, we discovered that not only was this creature well known, it was as common in their minds as any documented fauna. This certainly aligns with the legends, which describe the squonk's geographic range as very limited to these forests specifically. We wasted no time in establishing observation sites, complete with live traps and baiting stations, and focused our efforts on the densest regions of the forest, where the creature could presumably move largely undetected through the underbrush. It didn't take long before we were staring at, quite frankly, one of the most bizarre creatures I had ever encountered. The squonk is a creature of particular peculiarity. As the tales have told, it is small, approximately 16 to 18 inches tall. It possesses an elongated snout, large eyes suited to its primarily nocturnal lifestyle, and large pointed ears. These features are indicative of this creature's well-developed senses, which seem to provide effective navigation through the underbrush, as well as locating food and avoiding predators. Both its fore and rear feet exhibit limited webbing between the digits, likely an adaptation to the wetland forests it inhabits. In this case, the subject in question has already been given binomial nomenclature, Lacrimocorpus dissolvens, and I will occasionally refer to it as such from this point onward. In truth, full taxonomic classification of dissolvens proved more difficult than we anticipated. Many of its characteristics are unique, and many more do not appear to imply any specific ancestry. Though many interpretations exist, traditionally, dissolvens has been depicted as a kind of pig-like creature. However, the presence of semi-articulate digits rather than hooves make placement in Artiodactyla unlikely. A lack of armored scutes makes Cingulata unlikely as well, though foraging behavior is similar. And despite certain marked similarities to the Virginia opossum, the squonk is certainly not a marsupial and lacks a prehensile tail. Finally, the squonk's dentition is not limited to incisors, likely excluding rodentia. And so my team and I came to the conclusion that dissolvens belongs in its own family, Lacrimocorpidae. Until such time as more comprehensive genetic data can be obtained, its order will remain Incerticetus. As for myself, and partly due to its snout, I think it possible that this creature may share relatively recent ancestry with Tapiridae. And indeed, tapirs did once roam North America, but at this point this is little more than speculation. Dissolven's skin, largely absent of fur, is wrinkled and loose, folding in on itself and covered in numerous raised bumps that at least superficially resemble warts. And indeed, a near constant trickle of tears streams from its eyes, cascading down the sides of its face and even a large portion of the anterior body. Behavioral analysis reveals a shy and fearful creature, and it is little wonder why. In the wild, dissolvens is a potential food item for many mammalian carnivores, such as coyotes, black bears, and even cougars. But while it would appear that this creature has no defense against such predation, the local population seems quite healthy, if geographically limited. This is because dissolvens has developed a number of novel defense mechanisms. Let us begin with dissolvens' first unusual feature, its skin. As previously mentioned, there are hundreds of raised protrusions in the superficial dermis, but rather than being warts, histological analysis has revealed these structures to be highly specialized sebaceous glands, though with significant morphological changes from those observed in most other mammals. Typically, sebaceous glands are associated with hair follicles and secrete an oily substance called sebum, which traditionally helps to lubricate and waterproof the skin and hair. In dissolvens, however, these glands have become enlarged and modified. It appears that they are composed of a complex arrangement of lipid-producing sebocytes, interspersed with a dense network of capillaries and sensory nerve endings. This level of vascularization facilitates rapid secretion, triggered by neural signals associated with stress or threat detection. And in fact, the lipid compounds synthesized by these glands appear to exhibit a high concentration of volatile organic compounds, such as dimethyl sulfide and certain terpenoids, the former of which lends the squonk an unpleasant sulfuric odor, while the latter acts as an effective irritant to a predator's eyes and sinus membranes. Indeed, it appears that when dissolvens perceives a threat, the sensory nerve endings within these glands trigger an immediate release of these compounds, which may be enough to signal that the squonk is not an ideal food source. Then there is the aspect of the skin appearing loose or ill-fitting, as the legends describe. The reason for this unusual appearance is as yet not fully known. However, I hypothesize that such loose skin could be an adaptation to provide more surface area for its modified sebaceous glands, which in turn provides a more effective defense against potential predators. However, it could simply be that the amorphous shape of the squonk's body resulting from this loose skin could aid in its next series of defense mechanisms, each one more bizarre than the last. The legends of the squonk refer to another, quite odd aspect of its biology. According to some, hunting the creature is not difficult. Given the constant weeping resulting from its own low self-esteem, a hunter need only follow the trail of tears it leaves behind. In the course of our own investigation, we had no need to track the creature at all. Using a simple live trap baited with an edible fungus that grows in the region, we were able to obtain a total of 5 specimens for study within a relatively brief time frame. But even if we hadn't had such success, the idea of following a tear-stained trail is certainly hyperbole. And yet, interestingly, the image of the squonk weeping is not. To some extent, it appears that dissolvens does demonstrate nearly continual lacrimation, or the production of tears, from ducts more specialized than those found in other mammals such as humans. In fact, it appears that the tears themselves exhibit unusual qualities, with high concentrations of nitrogen-containing alkaloids, which themselves are known for their bitter taste and even toxicity. Though more study is needed to determine for certain, I hypothesize that these alkaloids are sequestered from dissolvens' diet in a somewhat similar manner to that of poison dart frogs. Additionally, the fluid itself is of a higher viscosity than one might observe in other species, likely due to a noted higher concentration of mucins. Further observations indicate that individual dissolvens will frequently spread these tears across their face, snout, neck, and chest, using their forelimbs in a kind of grooming ritual. In short, it appears that the squonk's tears are chemically engineered to not only remain on the skin for extended periods, but to induce taste aversion in predators. However, the production of the compounds found in these tears are presumably relatively metabolically expensive. As a result, lacrimation in normal circumstances is limited. But when dissolvent senses danger, a fascinating change takes place. Throughout the period of observation, my team and I made every effort to avoid inducing stress in these creatures. We made no sudden movements, spoke in hushed tones, and performed no invasive procedures on living specimens. It appears that dissolvens is a particularly skittish animal and of relatively low intelligence, prone to intense stress responses at even the slightest stimuli. One such response is what I have termed stress-induced lacrimation. When danger is sensed, it appears that the creature's autonomic nervous system triggers an immediate response in the lacrimal glands, leading to a rapid increase in fluid secretion. In fact, because the squonk's lacrimal glands are anatomically larger and more complex than those found in typical mammals, they are capable of producing a startling volume of tears. Within the glands, the acinar cells, primarily responsible for the aqueous layer of tears, appear to exhibit an increased number of secretory granules, resulting in the rapid production of large volumes of fluid. Additional, as yet unidentified secretory units appear to be responsible for synthesizing the aforementioned alkaloids and distributing them throughout the fluid. Even more interestingly, it appears that the composition of the tears changes based on stress level. The greater the perceived threat, the higher the amount of defensive chemicals. This implies fine regulation of these glands by the neuroendocrine system, enabling the increase in chemical production in response to environmental stimuli, an unexpectedly sophisticated mechanism if this hypothesis proves to be true. Ultimately, when a predator, driven by curiosity or hunger, comes into contact with the squonk, the taste of its tears acts as an immediate aversive stimulus. Over time, predators have likely learned to avoid squonks as potential prey, other than in cases of desperation. In those cases, dissolvens exhibits yet another defensive strategy, and one that has likely given rise to the most improbable aspect of its legend. If the foul odor given off by its dermal glands and the threat of a spoiled meal thanks to its noxious tears aren't enough to deter a predator, dissolvens has one more last resort method. Should its stress levels reach a high enough threshold, the squonk will enter a state of tonic immobility, also known as playing dead. This behavior, which can be observed in numerous organisms from insects to mammals, is induced by an overwhelming threat, and when escape is not perceived as viable. At that point, there is an observable increase in certain neurotransmitters of the central nervous system, including GABA and serotonin, which inhibit motor activity. As a result, tonic individuals exhibit muscular paralysis, slowed respiration, and decreased heart rate. At this stage, the mouth is often opened and the tongue expelled, very effectively simulating death. This alone can be enough to deter a predator, as many are specialized to hunt live prey. In fact, the immobile squonk essentially disappears from the predator's perceptual trigger zone, causing confusion. As a result, the predator may abandon the hunt altogether. But paired with its death-like odor and disagreeable taste, dissolvens has a high probability of convincing its attacker that it is not a viable or living food source at all. Interestingly, the creature's loose skin may also play a role in the further effectiveness of this behavior. When dissolvens collapses, its skin settles in a manner that, at least to the casual observer, seems to obscure its true form, appearing more like a lifeless, amorphous mass. In any case, if the predator does abandon it, if unharmed, the squonk will gradually recover over a period of roughly 35 minutes, none the worse for wear. But interestingly, this state of tonic immobility may serve yet another purpose. As mentioned previously, dissolvens is a nervous creature, and in certain cases wherein a perceived threat is both great and sudden enough, it appears that dissolvens will enter a state of shock, followed immediately by death. Indeed, observations of squonks in their natural habitat have documented instances of individuals dying suddenly when exposed to intense stressors, such as loud noises or the sudden presence of a predator. These stress responses appear to involve a massive release of catecholamines and corticosteroids, which ordinarily would lead to enhanced evasion, but in some cases can actually lead to cardiac arrest and organ failure. This kind of acute stress response is not unheard of. Several small mammals, such as rabbits, occasionally experience similar stress-induced mortality, though primarily when in captivity. It is possible that the aforementioned tonic immobility could be particularly beneficial for the squonk, as in some cases it may help to avoid the physiological cascade that leads to sudden death. This unusual and unfortunate response may also have been the primary source of a very peculiar aspect of the squonk's legend, that it has been known to fully dissolve in its own tears, leaving behind only a bubbling puddle. This is, once again, a fair amount of hyperbole, but with some grounding in truth. As we've seen, dissolvens is certainly capable of producing a great volume of lacrimal fluid. This, in combination with its tendency to play dead or exhibit fear-induced mortality, likely led to the perception that it was dissolving in its own tears. However, there is another notable feature of dissolvens physiology that could have contributed as well. You see, it appears that dissolvens cells contain unusually high concentrations of lysosomal enzymes, particularly cathepsins and lipases. Under normal conditions, these enzymes play a large role in an organism's metabolism and cellular turnover. However, upon the creature's death, the regulatory mechanisms that confine these enzymes within lysosomes are disrupted, leading to the rupture of lysosomal membranes, which in turn releases their contents into the cell cytoplasm and surrounding tissues. In essence, the high concentrations of these enzymes appears to result in a greatly accelerated autolysis, wherein dissolvens enzymes rapidly break down its tissues from the inside out, and thereby greatly accelerate the decomposition process. While not nearly as rapid as the legends tell, full decomposition has been observed to occur in mere days rather than weeks. Hypothetically, this could explain certain accounts of a live creature taken by a hunter having at least partially decomposed by the time the hunter reached his destination. Finally, there are the reports that this creature can be heard weeping, and can even be located by following this persistent and tragic sound. This proved to be true in part, though as we've established, dissolvens' production of tears is not related to emotion as such. The reason for the reported sounds is simple. Dissolvens' tone of vocalization is soft and high-pitched, and could be construed as the sound of crying. Of course, these vocalizations are simply used for intraspecies communication. I have been privy to a number of strange, and even, in their own ways, terrifying creatures, but I have rarely faced such difficulty in compiling my research as I have with this case. The squonk is a bizarre yet fascinating amalgamation of disparate features, with defense mechanisms and anatomical features that make it at once repulsive, intriguing, and yes, pitiful. It is little wonder why so many observers have attributed sadness to this creature. Even beyond its appearance and tendency to weep, so to speak, its fragile and skittish nature can do little else but elicit sympathy. Fortunately, despite its fragility, dissolvens appears to be thriving in this region, and I see no reason why it should not continue to do so. I will be the first to admit that I was skeptical as to this creature's existence in the first place, but with the benefit of hindsight, perhaps more of the woodsman's legends are worth pursuing. This video was made possible by the Opera web browser, whose link can be found in the description, and by viewers like you. Thank you, and remember, you matter.